now let's proceed with the chapter 2. No, chapter 2 is something called as plumbing equipments. Now the moment I said equipment, you people are, equipment is nothing but a machine. Can I say mechanical device which is used to bring some work, isn't it? So now we do have different pumps over here, and here the equipments are what? I can say equipments is over here sand filters. I can say equipments is over here a GRP tanks. I can say equipments is over here the pumps, isn't it? Yes or no? Grease interceptors, hair interceptors, these are all comes under the equipment. So we'll be seeing both the equipments in the terms of plumbing, I mean in the terms of water supply and in the terms of drainage. So these are the equipments we'll be seeing. So very first equipment we'll be discussing about over here in the plumbing water side now. So is what the pumps over here. And as per we know, we are into the construction field. So because we are into MEP, so this is a construction field over here. So mostly the pumps as per this and all this we do have is what? Centrifugal or reciprocating. What kind of pumps we do use online? Yes, very good. Centrifugal. So mostly maximum the pumps what we are about to see over here all are centrifugal pumps. Okay. So now very first pump, what we will be seeing is a transfer pump. Now, what is a transfer pump? In the moment I say transfer pump, the word itself is saying that it is used to transfer something. It might be a liquid, it might be a fluid, it might be anything. Okay, but let me read it out in a very detailed manner. A transfer pump is a pump you can use to transfer liquid from one place to another place in general, or the pump which is used to transfer the water from underground tank or ground level tank to the overhead tank. This is exactly the transfer pump function is to. For example, I do have a G+3 building at the basement or at the ground floor. I do have is what shall I say, sump over there. Okay, I mean a sump, a reservoir if you're getting confused. And from that reservoir, I do have a water. I need a pump to pump up the water from this ground floor to the roof. I mean on the third floor roof. Okay, because there is 3 floors. Okay, on that third floor, I need to pump up this water. Okay, and where? In that tank, in the overhead tank, and I'll call it as overhead tank. Okay, so just this is just to suck from the ground floor, pump to that tank which is located on the third floor. This is what a transfer pump. Make sure this transfer pump is nowhere connected with the fixtures. Don't get confused online. This is directly from this tank to that tank. That's it. Hmm. Next. And next is what a booster pump. Now, what do you mean by a booster pump? First of all, let me tell you what about booster pump. A booster pump is a pump which is generally being used to maintain the pressure, where the pressure is less, which is required. Okay, for example, I required 8 psi or 10 psi or 20 psi, where I do have a very less pressure. I need to maintain that pressure. So what I'll be doing, I'll be using this booster pumps just in order to maintain the pressure in the line. And in this also, we do have different things over here, because in boosters also we do have 2 different kinds of boosters. I'll just say you in a minute. So booster pump, as I said, you booster pumps are used where there is no pressure which has to be there, because we have studied yesterday that every fixture demands limited amount of water. I mean the required respective amount of water with the respective flow also, PSI. We have seen the pressure also, isn't it? To maintain this. If I'm not having that pressure, it will not work in a proper manner. Okay. So there are 2 kinds of boosters over there. One is called as main boosters, and second is we'll see that is pneumatic something we'll be saying. So first of all, let's talk about the main booster. What does the main booster does? The main booster is a pump, which is a booster pump. As I said, booster pump does what? So this will be at the ground floor. Okay, this will be at the ground floor or the very first floor of the building, and it will be in series connected 1 or 2 boosters. Okay, so now how it works is, for example, we do have a project of 6 floors of a building, and anyone is calling for a laboratory or anyone is calling for a shower at the 6th floor. Okay, so this pump will be getting on at the very next moment, This will be pumping up the water with the required pressure, with the required flow to the respective fixture. Okay, always maintaining the pressure in line. Okay, where there is less pressure. Now, how we'll be having less pressure? We'll be seeing this from the municipal and as per the what kind of system we are proceeding with. We'll be studying more in detail about this. What directly connected to the fixtures. Anyone is calling for any fixture, the booster pump will get on, pump up the water with the respective fixture with the respective pressure. Okay. Same thing. Main booster pump pumping directly from the series to all the building fixtures, as I said you. But where I was saying previously, what kind of system? Transfer pump. I said you transfer pump deals with only from this tank to that tank. It is nowhere connected to the fixtures. But here what happens? From this, it has been sucking the water and directly pumping the water to the directly to the fixture, where the available pressure is not sufficient to reach the water to the floor. For example, I do have a pressure from the municipal of 20 psi. For example, inline 20 psi pounds per square inch, but I have a building of 6 floors. Just now I said you. So do you people think that 20 psi is more than enough from the municipal? I agree that I do have a water 24/7 from the municipal. I agree. Then I agree that it has a 20 psi from the municipal. Okay. But do you people think that water which is coming from the municipal, which is round the clock and with the required pressure, which is more than enough for 1 or 2 floors? But what about 3, 4, 5, 6? Can it go with that much of head? I need some external thing, a pump over there to pump there, isn't it? Yes or no? So I'm dropping there the pressure because I know this. What is it? The static pressure is increasing. So what happens? This pressure from the municipal will automatically decrease. So I need some external source over there, isn't it? So this is booster pumps directly connected to the fixtures. As I said, you said that the roof also. That is the next thing I'll show you. The next thing over here, and this is how booster set looks like. And you was talking about this hydro booster pump or hydro pneumatic booster pump also some people will be saying. So now what do you mean by this? As you can see, this is also in series, two pumps. There is a pressure tank, there is a control panel. Now this is placed at the roof. Can you see? This is one project actually. This is at the roof. This is actually a real image. I can't show you. This is an Indian project. Okay, this is at the roof. Now, like Anish, what you said, let me get back to you this and try to relate this. For example, Anish, you said that you have a gravity system over there. The water pumping from the transfer pump, it is going above and coming from the top. You said that ground floor will be having huge pressure. Agree. But at the same time, think what about the sixth floor, the where the overhead tank is being placed, only this much of slab, okay, like 5 inches or 6 inches, and afterwards the pipe is entering like maybe I'm saying 3 feet or 4 feet maximum. I'll be having a shower over there, isn't it? Because the floor FFL height is what? I'm talking about residential. We consider as 10 feet. Commercial, it might be 12 or 14, the maximum, isn't it? It depends. It is an airport or something, it might increase and increase more. So what happens? Do you think that I do get a required pressure because of this much of gravity force? From 6 will be very low pressure so to that fixtures on the 6th floor. Again, the water is traveling to the 5th. It will be somewhat a bit higher when compared with 6. It means the fixtures which are working at 6 will be more performing in a better manner on the floor 5. On the floor 4, more better. Floor 3 more. And at maximum pressure I will be getting where? At the ground floor. No, no. So to avoid this, and it is not recommended. So what I'll be doing, I'll be having this boosters over there. Boosters. So what boosters does is, again, whenever it is being taken care by the top floors, okay, top 3 floors generally, if it's a high-rise building. So generally top 3 floors is being utilized or designed a booster pump mostly for the top 3 floors because from the top 4th floor, if I calculate, the gravity force will be so much that it can attain that much of force, which is more than enough for the pictures to perform in a proper manner. Okay, so, so there are two boosters there. One is main booster at the ground, one is hydro booster, which is at the top. And this would be very small because of what? Only top 3 floors. Okay, okay, Anish. It might be 1 or 2 floors also. Mostly very high rise, we go with calculation for top 3. Next one, This is a hot water circulating pump. Now what do you mean by this? A hot water circulating pump is nothing but it's a circulator, small kind of pump, which is generally being installed in line. In line means on the line or in mid of the line, where what happens is it is just to suck the water from some area and it rotates the water in 360 degrees. So in short, if I'm not wrong, I can say it in this way: the starting point and the ending point is one and the same. For example, if I'm drawing a circle, I pinpoint it from over here, I have rotated a pen in 360 degrees and I'll be having a circle over there. At the starting point, that will be the same ending point also. Online, relating this. Yes or no? So what happens over here? No, Mudassir? It is a circulator which is forming a loop over there. For example, take example of a clock. Okay. So now this is we do have 3 needles. Let's talk about a seconds needle. It started from 12. It rotated 1 to 12 again. So it is what? 1 minute, isn't it? So to complete 1 minute, the starting point and the ending point same. So what happens in the circulator pump? Generally in the circulators or hot water circulating pump, what we are about to deal up or what we are seeing, it is being generally seen in terms of central system. A central system means the central heater system. So what happens? It sucks the water from the heater, it rotates to the complete hot water piping. Okay, and again it is coming back to the heater. That's it. So this is a circulator. So it forms a loop complete. You understand loop, right, online? Take any one example online. This is a central heater I said you. Okay. Following online. Okay. So in this is first of all the city main line. As you can see, the cold water blue color, it's going in. And we know this. This is heating element over here. The water starts heating up. It might be any source, electricity or something, whatever it might be. The water is getting heated up now. The moment heated up, what happens? I'll be having a circulating pump over here. Like you can see over here, this is a recirculation pump. It's actually not a hot water circulation pump. This is a recirculation pump. So what hot water circulation pump does is, this will be connected over here in this line, in this line, in this hot water line. Okay. What happens? It will suck the hot water in this manner. For example, this will pump up the water in this manner. It will go in this way. And again, it will pump the hot water in the heater. Why so? While the water is being transferring from here and here, I'll be having bathrooms over here, something, 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 something. So anyone calls for the hot water will be getting hot water at the very instant of time. Or else what happens, you people might have experienced this. If we don't have a hot water circulating pump, we are we need to wait for certain amount of time till the cold water is being drained in the line of the hot water. Okay, when it is being drained, I'll be getting a cold water. Oh, sorry, hot water. So to avoid all this, always this hot water will be circulating in this way, like round and round, round and round. The complete piping, it will be pumping up the water. Anyone calls? Okay, the water is available right away at the moment. It is passing through that fixtures only. If it is not being used, what happens? The water is not being used. Okay, it will check. Okay, it's not being used. Again, the water will goes directly and dropped into the heater. Again, pumping. Again, same suction and all this. Yes, yes. That is why we need this hot water circulating pump to avoid what? To avoid the wastage of the cold water. Okay, because as I said, na, anyone calls for the hot water, I'm opening the hot water, but I'll be getting first of all the cold water. I think you people have observed this. I need to wait for certain time that the cold water should drain out first of all. And that is again what we are spoiling, or we are like draining a water which can be used for no purpose. I drained it, and a natural resource. I need to save that, isn't it? So that's why I need this. Yes, automatic. It depends now. It depends on something like what? Like we'll be calculating this hot water circulating pump, which has the complete lining. I mean, how much the piping and all this we'll be calculating, and we'll selecting a pump. All it does is the moment the water level reaches, it sucks this and it will be serving this. Okay, by means of we do have some kind of arrangements over there in terms of what we do have this. Okay, this much of level it will be suction. And when the water level reaches like 60 degrees, for example, we do have some kind of things over there. Okay, 60 degrees, it will be suction, then it will be pumping of the water, because it has some commands. Okay, we have fixed this when it reaches, the heater reaches this much amount of water, it is heated by the thermostat or something, it has been interrelated. You have seen the control panels also over there, we do some settings over there. Okay, that is different. But this, what I'm saying right now, you're talking about the installation. Now what I'm saying is hot water circulating pump is used for this, which creates a loop and which is only and only just here to pump up the hot water in a loop from where it started. Again, it will go and drop the water over there. Why? Because to avoid all these things which causes this discomfort. Okay, and it creates a loop. That's it. I mean, at 360 degrees. Relate this online in a central system. It is used to circulate the hot water in central heating system. A circulator pump is a specific type of pump used to circulate gases, liquids or slurries in a closed circuit. This is very important. They are commonly found circulating water in central heating system. This is very small amount of pumps. Like this might be quarter HP or 0.5 HP I have seen maximum, because very small pumps just to rotate the water. It's nowhere something like pumping the water to G+6 or something, isn't it? Just in line. So this is a hot water circulating pump. Now let's see about a pump which might be used in terms of water as well as in the drainage side also. Submersible pump. The submersible pump is a pump which is totally submerged into the water. We have seen, if I show you this image, you will be getting this. For example, we do have bores done in our homes and we do have these things only. This has been done a bore from this, and we do have, this is our pump over here, what you're saying, it is submerged and it will be having one electrical wire in this way. You have been seeing this, isn't it? If we, this is completely, we open this, we do have a kind of mesh or a strainer over there. Behind that we do have a motor which rotates when, and this will be, this wire will be also be completely submerged. For example, if it's 100 feet, 100 feet of wire will be there and connections. The moment we open this, now this will be rotating energy because it's centrifugal pump again. So rotating energy will be converted to potential because potential is moving. Then potential will be converted to the pressure energy. Why? Because of this pressure, the water will be coming over here. We do have generally in our homes in India especially. Yes or no online? Yes. Anish. So this is the pump over here. Let me read it out for you people so it will be much easier. A submersible pump, also called an electrical submersible pump, is a pump that can be fully submerged into water. That means it is completely dipped into the water. Okay, the motor is hermetically sealed and close coupled to the body of the pump. A submersible pump pushes water to the surface by converting rotatory energy into kinetic, then into pressure energy. What I said, the same thing. Okay, so this is one more kind of pump over here, the submersible pump. Why submersible? Because it's already into submerged into the water. Let's talk about the pressure tank now. The pressure tank is something we'll be seeing in the terms of boosters, in the terms of mostly in booster sets we'll be having, or in transfer pumps also we'll be having. No, sorry, not in transfer pumps. We'll be having only in the booster sets. Okay, so the combination of pressure tank and a pressure switch, the pressure tank and pressure switch, and the pump is what allows. Okay, first of all, let me tell you how it exactly works. For example, this is a pressure tank, what he's talking about, and this is a pump. This is a discharge. This might be a suction or discharge, may a discharge. Okay, and there is a pressure gauge. So now, for example, online, if this is a suction, the water is suction is being done from over here. The water first passes in this manner and fill this pressure tank, and this pressure tank is compressed with air over here. Okay, this, that's why it's called as pressurized tank also, because it has a compressed air over there. Okay, so it will be half filled over here, and we need to calculate this as per the pump inlet and outlet or the cut in or cut off of the pump. Okay, so we need to design this also 50 liters, or generally you'll be seeing this pressure tank in commonly from the manufacturer. I'm saying 50 liters, 100 liters, 200 liters, 300 liters, 500 liters. I'm talking about residential and commercial. It might go to 3000 liters also. Now this is very dangerous thing. It might blast also because of excess pressure. Okay, so as according to me, this might be a discharge. As I can see is over here is what a pressure gauge. So I can say, okay, this much of pressure is being delivering in this, and this is a copper piping. So what happens, what this pressure tank does is when it is being filled over with the water completely and there is a complete top is the compressed air over there. Compressed means for sure it will be in pressure. So when it is being filled, the water goes and pump up the water to the respective fixture. So what happens if it is not there, for anyone, example, anyone is calling for any fixture, for example, 100 times a day in one floor. So the pump needs to get 100 times for one floor. And if example, if there is like kids in the home, if they are opening this and that, so what happens? The number of times the pump gets on and on and on. Booster set, which is not at all recommended because we need to save the sources, as I said, you natural. So what happens, first of all, I'm increasing the running cost because every time anyone is calling for any fixture, the pump needs to get on and pump up the water, first thing. Second thing is what, uh, the pump needs a quick maintenance because it is used so much of time, isn't it? So these are the things over it. To avoid all this, what happens, we need to calculate this pressure tank. And what is the function of pressure tank? First of all, let me tell you, pressure tank is something which has a pressurized air inside. If someone is calling for a limited amount of water requirements, for example, I can say for a lavatory or for a kitchen sink, not huge amount of water, like for not for the bathing and all this. So what happens? It will not allow the pump to on because the water is under pressure because the air is compressing from top. What happens? This will compress the water and send to the respective fixtures. So what happens? This will avoid the pump to on, okay, and to pump up the water. So this way the pressure tank is being utilized. Okay, so it is saving this running cost and it is giving some more boosting to the life of the pump, I can say, in this manner. Okay, so we'll have a calculation, we'll see this later on. Just right now, just okay, see this, okay, how and why the pressure tank is being placed. It is a very good option because only boosters, and that is expensive, it's a machine, so it needs a quick maintenance and all this. So if there is a sudden breakdown and all this, then there will be no water. To avoid all this, we do have this kind of tank over there, a pressure tank.